So up to number 8 of these questions now. This one is about just working out some problems with repeated applications of the chain rule. So there's the question. It's a differentiation question where you need to differentiate that function that's in terms of p's and q's, but just do it the same as you would with y's and x's. So pause the video and have a go. So in terms of doing the chain rule, your formula sheet has 2 formulas that you can use. I prefer using this idea. So I'm not going through the problem and identifying this thing's u and writing u equals ln of all this, and then I'm not doing dy du's all the way through. Okay, I'm just going to try to simplify the working process. So if I'm trying to differentiate p, I know that when I differentiate sine, it turns to cosine. Okay, so I know it's going to be 7 cosine of all this stuff in the brackets. Okay, which is the first part. Okay, differentiate that function with the g in there, and I need to multiply by the derivative, so d dq in this case, of what was inside here. Okay, so I'm really just setting myself some smaller jobs to do. So in the next line, I need to do a little bit of rewriting, but I think it's a reasonable trade-off. So rewrite this first part. Okay, and then I've got another job to do. So it tells me, hey, you need to differentiate something that involves natural log. So I know to differentiate natural log from the formula sheet, it turns to 1 on x. So I just need to flip this thing over. So all good. 2q plus 3 on 3q minus 6. But I got to remember this is a chain rule problem again. So I need to multiply by the differentiation of what was inside those brackets. Okay, so you can see all I'm doing is just one thing each line and setting myself little smaller jobs. So again, do a bit of rewriting. So now that I come to doing this differentiation, I notice that's a quotient rule. So I'm going to do that whole quotient rule just off to the side. So I go off to the side and do my whole quotient rule for that function, and I can just write the result in here. So the differentiation is essentially done here. Now it's just looking for, is there any simplification that we can do? So I'm just looking at these 2q plus 3's. I'll be able to cancel some of them there, and on the bottom, got a bit of a common factor. So just taking out the common factor 3 there and cancelling this with the squared on the bottom. So 21 on 3 is just 7, so 7 7's 49. Okay, so this is what the derivative should be. And just a little trick, if you need to use this result for something and you're worried that you might have made a mistake in the differentiation, you can just check out just a number. So let's test what's p of 5 by putting 5 into this formula, and also just getting a calculator to differentiate that at 5. So depending on your calculator, it'll look different, but the top one is me just putting 5 into my derivative, and the bottom one is me differentiating that function with 5. So it's not foolproof that it's definitely the right derivative, but I'm pretty confident that that's all good. So you might want to compare that sort of way of doing chain rule with the way that the textbook solution did it and made a mistake. So using this idea for chain rule, probably not necessary if you're just doing methods. If you're doing specialist with the related rates, then yeah, you'll need to use that formula, but some students find this way a lot easier. So yeah, good luck differentiating and good luck for your exams.